I'm Marin, and I'm here at Start Camp.
And I'm Eliza. I'm a director here at Star Camp. And today we're going to be talking about spacesuits and how to stay cool in space. Because there are a lot of different dangers out in space. First of all, there's no air. Space is a vacuum. And that creates two different problems. We can't breathe. That's problem number one. Problem number two, there's no air pressure. Air pressure pushes down gently around us on all sides. But if there's no air pressure, our bodies eventually expand and go expand and expand and expand until we explode. And that's a big problem. We don't want to explode in space. There's also the problem of radiation. And radiation can come in all types and all different areas in space. And it can cook us like you would cook something in a microwave. And we do not want to be a cooked human in space. We've got that, and we have micrometeoroids. These are very tiny objects that are hurtling around at thousands of miles an hour. They could pierce us through our spacesuit like a bullet, and we really don't want to be hit by a space bullet. And the problem we're going to talk about today, though, which you can simulate at home, is temperature. And temperatures in space are a little different than they are here on Earth. Temperatures are extreme, meaning they can go super, super, super hot, or they can go super, super, super cold. And both are a big problem for us as humans, because we like things in a nice middle. That's why we have an atmosphere on Earth. So we have our spacesuits, which act like our own personal atmosphere. And in the spacesuits, there are a lot of layers. And the layer we're going to be talking about, which you can simulate, is the thermal cooling and ventilation garment. The thermal cooling and ventilation garment is how astronauts are able to stay cool while they are in space. The thermal part keeps them nice and warm. It's kind of like a layer of long underwear. But the cooling part, how do we stay cool? We're going to show you. There is tubing that goes all around the spacesuit. And we have tubing in your kit. So with your volunteer, have them hold out something. An arm works wonderfully. And wrap the tubing around their arm. Make sure that you leave a little excess at both ends. And you're going to need 2 containers that are full of very cold water. One right here, that is full. The other right here, that is empty. All right. How's that feel? Not too snug?
Snug, but not too snug.
Snug, but not too snug. That's what we're aiming for. Because if it's too snug, we're going to cut off circulation. And that's a whole other problem. All right, take one end of your tubing, placed into your cold water. Take the other end of the tubing and pretend like it's a big straw. And take a nice long slurp. When the water hits your mouth, take your empty container and put the tube in it, and then move it to a lower elevation so that gravity will pull the water through. Right. As we're having this very cold water going through the tube, tell me what you feel, Marin. Ready?
Here it goes. Oh, it's so cold.
Yeah?
It's cold.
All right. Is it cooling your arm down?
Yeah.
That way, even though an astronaut would be in a thermal layer, they're still able to keep nice and cool while in space. Thanks for watching, everyone.